In this video, we're going to do a few examples of drawing alkanes. On the paper in front of me, I've got 3 names for alkanes. They're all branched alkanes. I'm going to go over a couple new things that you might not have come across. These are things I haven't explained in any videos so far. I picked some more complicated examples on purpose because there's always going to be little exceptions or things that I miss in previous videos, and I figured this is a good time to cover it. So let's go through these one at a time. If you already think you might know how to do it, I encourage you to pause the video and try it out on your own, and then come back to the video and see how I solve it. So in the first question, we've got 3-propylbutane. So let's go ahead and sketch this one out. So there's a few things I need to look for. There's clues here. It's has a root of but, and its suffix is ane, so that tells me that it's a 4-carbon chain. And I'm going to draw line structural formulas. So there's my 4-carbon chain. Each point represents a carbon. And then it tells me that there's a propyl group at carbon 3 on the main chain. So a propyl group is going to be, propyl is the root for a 3-carbon chain, and a propyl branch would be 1, 2, 3, 3 carbons coming off of the main branch. All right, so what does that look like? So here's my main branch of carbons, 1, 2, 3, 4, the main chain. And it says I've got a propyl group coming off of carbon 3. So I'm going to number my carbons, 1, 2, 3, 4. And if there's a propyl group coming off of carbon 3, that means I have to draw a branch with 3 carbons coming off of carbon 3. So it'll be 1, this is 1 carbon, 2, and 3. And notice how I draw my lines at, there's 120-degree angles roughly between my my lines here. And there you go. And as I do this one, I actually notice that the name itself is incorrect. There's a problem with the name, because if I draw this structure out, you're going to notice that if I name it, if I was going to name this structure without knowing that this is the name given to me, I wouldn't name it 3-propylbutane. So there's an issue with the name here. So maybe pause the video and figure out like what's wrong with how this structure is named. So here's the issue. The longest continuous chain is not a butane. The longest continuous chain is not 4 carbons. It's actually 1, 2, 3, 4, 5, 6. It's actually 6 carbons in length. So the longest chain, I'll draw it in red, is 1, 2, 3, 4, 5, 6. So that is the longest chain right there. And instead of having a propyl group on carbon 3, we're left with a 1 carbon off of carbon 3, which is a methyl group. So instead of calling this 3-propylbutane, it should actually be called 3-methyl 6 carbons, so that means it's hex. 3-methylhexane. It should actually be 3-methylhexane. So glad we caught that mistake. And that's sometimes the case. Sometimes names show up in questions like in your textbook, and the name is wrong. And you can, from the wrong name, you should still be able to draw the structure, the accurate structure. But once you draw the structure, it might become apparent then that the name is wrong, as it did just now. Okay, let's move on to the second one, 1,3-dimethylhexane. Hopefully there aren't any mistakes with this one. I don't think there will be. The root is hex, suffix is ane, so that tells me it's a 6-carbon chain. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there's my main chain, and then here's the new thing that I didn't go over in previous videos. I have 1, 3, so I've got two numbers beside each other, and then I have dimethyl. So di tells me that there's two methyl groups, and the two methyl groups are located at carbon number 1 and carbon number 3. Okay, carbon number 1 and carbon number 3. So let's draw those ones out. So carbon number 1, so 1, 2, 3, 4, 5, 6. Carbon number 1, I'm going to add another branch. Uh-oh, I have a feeling this name is wrong again. And it says I have a, so this was carbon 1, 2, 3. There's my other methyl group. So one methyl group was going here, the other one is going there. But notice what happens when you add a methyl group to carbon 1. What happens to the length of the main chain? It gets longer. So this name, it's kind of funny, it's the second wrong name. There's an issue with this name also. So what's wrong with the name? Well, the longest continuous chain of carbons is not 6, it's actually 7, because when you add a methyl group to carbon 1, it just elongates that chain. So carbon 1 should actually be that methyl group we just added. So it should be 1, 2, 3, 4, 5, 6, 7. So instead of having a dimethylhexane, it should just be one methyl, like a methyl coming off of carbon 4. And it's not a hexane, it's a 7-carbon chain, which is heptane. So this should actually be called 4-methylheptane. That's correct. Whereas 1,3-dimethylhexane doesn't really work. The one thing I wanted to make note of here is this di. So usually in names, if you have two groups that are the same carbon length, or two branches that are the same carbon length on the main chain, you indicate where they occur using these numbers, so 1, 3, and then di tells me that there's two of those groups. There's other words that might get used here, so you might also see tri, which you could figure out is probably going to be 3, and the other one you'll see is tetra. And they just tell us where those branches occur. And you usually use that when you've got branches coming off of the same carbon on the main chain. So we're going to see an example of that in our third one, and let's hope this one has no mistakes. I don't think this one is going to have mistakes. Anyway, that's a good learning experience, kind of going over these, like writing out the structure from a faulty name and then identifying the correct name from the actual structure. Okay, so let's handle the last one. This is 4,6-diethyl-2,5-dimethyl nonane. So the root is non, so that tells me I have a 9-carbon chain. Ane tells me it's just an alkane, which means it has carbon-carbon single bonds. No double bonds, no triple bonds. Okay. And then the prefix is actually quite long. So I've got this section here, 2,5-dimethyl. So that means I have methyl branches at carbon 2 and carbon 5. And then 4,6-diethyl means I have 2 ethyl branches at carbon 4 and carbon 6. And the 2,5-dimethyl means I have 2 methyl branches at carbon 2 and carbon 5. So let's draw this out. Nonane 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my 9 carbon chain. And let's deal with the 2,5 dimethyl. So we'll start here. This is carbon 1. 1, 2. So at carbon 2, I'm going to have a methyl group. At carbon 5, 1, 2, 3, 4, 5, I'll have another methyl group. So that one goes right there. At carbon 4, I have an ethyl group. So carbon 4 is right here. So there's my ethyl group. The ethyl group is going to have 2 carbons in the branch. And then at carbon 6, I also have an ethyl group. So 1, 2, 3, 4, this is carbon 5, 6, 7, 8, 9. There we go. And that looks like the correct structure. You can do a double check, just make sure that the longest continuous chain does have 9 in it. Yep, that's the case. I have my methyl groups at carbons 2 and carbon 5, and then I have my ethyl groups at carbon 4 and carbon 6. So this one is good to go. Good structure. All right, that's it for this video. There's quite a bit of content packed in. We uncovered that our first 2 names are incorrect. After drawing the structures, we found the correct names after finding the longest continuous carbon chains. That's usually where you're going to see the mistake if a name is incorrect. And then we handled this one here. There was no corrections we had to make, and this had multiple branches coming off carbons. Okay. One thing you have to look for, like if you see the prefix di or tri or tetra in front of an alkyl branch, like ethyl, methyl, propyl, whatever, that means there's more than one of those branches coming off the main chain. Where those occur are indicated by the numbers that come before that prefix. All right, that's it. See you in the next video.